Hello everyone, my name is Kelly and I'll be taking you through this introductory video to the Akrometrix Automated Report Generator solution. Automated Report Generator is integrated into the surface analysis software for the Akrometrix equipment platform. By replacing the current standalone report generator software, we'll save users a lot of time in communicating thermal warpage results. Additionally, the added automation will reduce mistakes from manual data entry as well as standardized reporting formats amongst different users and companies. The basic concept starts with the phase and displacement image data files that come from Akrometrix thermal warpage equipment. Inside of these files resides all kinds of data about the system, setup, and thermal conditions under which the data was taken. We call this metadata. Akrometrix files have contained metadata for some time, but for the first time we are leveraging this information to automatically organize, categorize, and report on what this data tells us. Recall the legacy report generator software found here in Studio Manager. This software is used to create visual reports through a manual drag-and-drop interface. Additionally, most customers were required to use third-party programs to summarize gauge results. Our new automated report generator software is now embedded within Surface Analysis. To explain this new capability, let's first look at Surface Measurement and Thermal Profiler. When taking warpage measurements, the Studio software tracks numerous details about each measurement. We can use these details intelligently to automate the reporting process. You will notice some new fields in Thermal Profiler to record metadata. For example, Test ID is essentially replacing the Profile Run Name field. Note the tag buttons here that have been added to Thermal Profiler. We'll talk about these more later. You can see a file's metadata in Surface Analysis. Let's look at the legacy reporting workflow. Phase image files are created in Surface Measurement and Thermal Profiler. Users manually organize phase images in Windows folders. The files are analyzed and pictures are generated, organized only by file name. Gauge information is taken from a text file and imported into a program such as Excel. Picture files are manually organized and added to the report one at a time. These two workflow paths combined are used to communicate final measurement results. Let's go through a brief example of the legacy workflow. Here, files have already been organized in Windows by the user. File analysis is performed and generate output is called to create picture files. Now in Report Generator, things such as titles, temperatures, and graph types are all set manually per image and per page. So, in the interest of time, let's fast forward the clip as we enter text into the different titles. Next, all files must be manually dragged into the report by the user. Users familiar with this workflow know the extensive time that may be involved in creating these reports. We'll finish this 4-page report in record time, but one can see here how poorly this manual process scales for large data sets. Now let's look at the workflow for the automated report generator solution. Phase images are created in the same manner in Surface Measurement and Thermal Profiler. However, in Surface Analysis, the files are grouped and analyzed based on the metadata they contain. Note that file organization in Windows no longer matters. We have not removed the ability to create pictures and text, but these files are not part of the main workflow. Instead of creating picture and text files as outputs, the final report is created within Surface Analysis. Generate Report pulls from each file's metadata to create the final output with a single click. Let's look at these new features within Surface Analysis. We'll start by looking at the source folder for analysis. Here, multiple folders can be loaded. Recall again that the Windows file path is no longer critical for organization. Source folders can be made inactive or inclusive of subfolders optionally. Furthermore, files can be filtered by their file names. Here, we have excluded search area phase images from our analysis and have the remaining files for 2-part track samples in a 6-measurement profile. You'll notice that the files are shown in the results table prior to clicking Analyze. The Generate Output function remains, but it is no longer part of the main workflow. By default, output files will not be shown as created due to a new multi-core processing capability. This multi-core processing can be toggled off to see each individual picture as it is generated at the sacrifice of speed. In our new workflow, the Analyze function will now create new displacement files. This is a critical change, since using generate output is no longer in the primary workflow. Optionally, grouping can replace analysis as the first step in your workflow, allowing filtering of unwanted files prior to analysis. Grouping prior to performing analysis will also speed up processing time by avoiding analysis of unwanted data. We'll spend the next few minutes going over the three main tabs of our new report generator interface. These include the Groups, ROI Selector, and Layout Settings tabs. First, the Groups tab. The top half of this tab works the same as our source folder input. At the bottom, we see our grouped results. These include numerous details about each group. In this case, we have two different regions of interest. The middle of the screen shows our grouping parameters. These numerous settings are used to organize our files based on the metadata they contain. Some examples include differences in acquisition or set point temperatures, quantity of temperature profiles or ROIs, differences in location within the camera field of view, difference in image size, along with a number of other metadata fields. For this example, we changed the max number of ROIs to 1 and click Group. This now creates two groups based on our two different ROI names. Next, the ROI Selector tab. Here you will see a thumbnail view of all results separated by group, region, and temperature. This does not reflect the final report, but instead gives the user the ability to exclude data from the final results by clicking on the thumbnail. Various information about each group is given at the bottom of the screen, making it easy to identify noisy or unwanted data sets. Before we show the final tab, we need to discuss metadata and how to access embedded tag information. Each metadata category has a specific name. When surrounded by greater than, less than symbols, this metadata becomes a variable input to the final report. For this example, our phase image has an ROI name of BGA1 and an acquired temperature of 150°C. Using the listed tag input, we combine metadata variables with common text to get the desired report label. In most cases, direct links to use these file tags are provided. Going back to surface analysis, we're now ready to explain the Layout Settings tab. The top section of the tab provides details about each group along with numerous fields to input labels for each file. These fields will actually determine the details of the final generated report. Group order can be changed along with gauges used for each file. Here, a metadata tag is set by default to label the different samples within a gauge report. To exercise some different options, we can change the image title, removing the region of interest name from the title, and instead show this information as a subtitle on each page. Keep in mind that any common text or metadata can be used for any of these fields. We'll just put Akrometrix for the title of our report. The lower half of the Layout Settings window begins by selecting desired graph types. Footers for each graph type can be selected using a number of available metadata tag options. Within the highlighted box, you will see Profile, ROI, Graph Type, and Temperature listed in two separate tables. By moving the four variables up and down, the left table orders the priority of each variable in the report. This determines the order of images shown in the final output. Similarly, checkboxes are provided to determine whether a change in one of the four variables starts a new report page. Here, order does not matter. Two report layouts are provided. The 6-up layout matches with the legacy report generator format, while 24-up creates a new landscape report layout. Just a few more options to choose here, including units and common Z-scale options. Finally, we can create our PDF report by hitting Generate Report. Let's take a look at the results. Gauge graphs and tables will always be created, one per group. Any number of chosen gauges can be plotted here. As we flip through the report, you can see the new 24-up plot layout. For this report, we have two groups. If these two samples were left in a single group, two data sets would be shown in the graph and table. At this point, all of the base functionality of the new automated report generator has been demonstrated. To round out our video, A final example is shown working beginning to end from data acquisition to reporting. Here we see the camera window showing 2 larger samples and 4 smaller samples. We'll manually define regions around our 2 larger samples and allow park tracking to capture the 4 smaller samples. Note that this in itself is new functionality. Once our thermal profile is complete, we can point to the source folder containing all files and proceed through the established workflow. We'll group the files first, separating the large samples from the small samples by their difference in image size. Please watch as the rest of this practical example is shown. We'll flip through the generated report to see the result of our quick practical example. Thanks for watching. Automated Report Generator is one of the multiple features released in the Akrometrix Studio 8.0 software. Please contact your local Akrometrix representative to find out how to upgrade to the latest Studio version.